Well, for the people who printed out early, you get to decide when we have our midterm exam.
Those are our choices.
Here's are your choices.
Are we assuming that we're all going to pick the latest one?
Can you flip a coin?
25th, 30th, 23rd. Not the 30th. Yeah, maybe the weekend is 30th, but then we can say the same thing about the 23rd. If it goes, it's definitely going to be the same those 3 days no matter what, right? It's not like to get harder if it's later. Cover more material, it's going to be more material.
Well, the material on the exam is going to cover whatever we cover before the exam.
Yeah, that's why they're, if you do but we also have that, it's the 16th as well. If we finish the assignment on 16th, that gives us a week to prepare.
Right.
Yeah, that's enough. I feel. I can use less sleep, right?
October 16th. Gives you 3 weeks.
Do we have anything due? Yeah, I'm kind of thinking. All thing I don't know is when to lose.
So, the 23rd. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 25th. 1, 2, 3, 4, 5. The 30th. 1, 2, 3, 4, 5, 6. 7. Okay.
Alright. So the right after what's the stuff? Yeah. Well, it'll be fresh. Yeah, it's just true. It'll be fresh on this. That assignment was wild, man. You know if it'll be in this room?
Yeah. Finding a larger room at this time is not going to happen.
And this is the midterm.
Right. So the thing about remember about patterns is they're not like algorithms, right? You know, when you study quicksort, you can pretty much say this is quicksort, right? And there might be a few tweaks you do to optimize it in a particular language, but that's it. I mean, we're done, right? When we talk about a pattern, we may have to adapt it to the current situation. So I think it was yesterday on the wiki seminar, what do I do about returning the value? Well, it depends upon what you need, right? It may be that when you execute a command, it returns that command, execute something where you need the result. Well, if that's the case, then your command has to return the result you need, right? And if you have to return it, you have to return it. Then you have to figure out what type to return because, you know, the situation demands it. If you have to return on, if you support undo, that gets really more complicated because, you know, when you create the command and give it the command processor and say do it, you know what the command was, right? So you have an idea what should be returned. But if it's like, well, undo some arbitrary command, you know, that becomes really hard to deal with. But again, it depends upon the situation and what's required. And so when you look up these patterns online, that may not be the way you use it in real life. Now in assignment 3, we'll look at the memento pattern for undo. And assignment 3 will probably be the biggest assignment, and they get smaller after that. What's that? The largest. Largest.
Yeah, this was pretty large. The other priority queue was pretty, or assignment 2 was pretty big.
You may change your mind after you read assignment 3.
Thanks, I feel better.
So I want to look at, there's several patterns which are closely related. The Memento pattern and the command pattern are related. In fact, they both support undo. I want to talk about the state pattern because it looks so much like the strategy pattern. And so the goal of the pattern is to, right, allow the object to change its behavior based upon its state, right? So depending on what state it's in, right, its behavior is different. And the structure is pretty much the same as the strategy, right? You have some sort of context which holds the state. There's some sort of interface for the state. And then you create concrete subclasses, and then certain operations inside the context do their operations by calling some operation on the state, which is pretty much the same structure as the strategy, right? Now, the way it can appear to change behavior is if I replace which concrete state is actually in that field, different concrete states can implement the same function differently, behave differently, right? Which again is just what the strategy does, right? And so, a fake example I created, say we want to run a program to view grades, right? So you need to view assignments, you have to log in, you want to view your grades, the instructor has to log in to post grades, right? So different types of operations we want to do. And there's different states, right? And so when you're not logged in, certain operations which you can say view the dates of the assignments because anyone can look at the dates, it's not secure, right? And you can log in, but we can't allow you to look at your grades or post grades because we need to know who you are to know whether you're allowed to post grades, and we can't let anyone but you see your grades. So those are invalid operations, right? So if you try them, you basically say, sorry, but you can't do it. Now, if you're logged in as a student, right, then you can view the dates and you can view your grades, but you can't post grades, and logging in doesn't make any sense because you're already logged in. And when you're logged in as an instructor, basically you do everything except log in again because you're already logged in. You have to log out first. So depending on what state we're in, the application's in for a particular user, depends upon what operations we can do and which ones we have to sort of say, I'm sorry, but this is not allowed, right? And so we could think of, we're going to build a server, and maybe we have a, an Android and iOS client will talk to the server, right? And they will then, the clients can send, requests to the server, log in, view grades, et cetera, and we have to implement a server to handle response, right? So how do we do that? Well, one way is we've got a class that, we're not doing much, but when it gets a request to view grades, you have to check, are you logged in? If you're not logged in, then, redirect to log in or send back an error or something, right? If you're logged in as a student, then we do this, right? And if you're logged as an instructor, then, so basically every operation in this grader class becomes a case statement. Now, are you not logged in? Then everything does something, and then if you're logged in as a student, you do it this. Logged in as instructor, do this, right? So every function, every method is basically, since we've got sort of 3 states, is a case statement with 3 cases. And if there are more states, it would have more, the case statement gets bigger and bigger, right? Well, then it's the same thing. Every one is just a case statement that directs us to what we want to do. So in the state pattern, again, what we're going to do is we're going to create a separate class, separate hierarchy, separate from our grader program. And so we'll create an interface. If we're in Java, if we're in Python, we can just write down the methods we need, right? Because we don't have interfaces. And then we'll create 3 separate subclasses, right? And our grader state, we've got login and view grades, post grades, right? Now, when I implement not logged in, what does the view grades and post grades function going to do? It's going to say, sorry, right. And the login state is going to say, okay, give me your password, give me your username, I'll check, and then either true or false, right? And that's it. It doesn't have to worry about the not logged in state, doesn't have to worry about what you do when you're an instructor or when you're a student, right? When we implement the student subclass, it has to have those methods, right? And the login method is going to like, I'm sorry, but you already logged in, right? It doesn't have to worry about the cases. We don't have to worry about, and view grades, okay, we're logged in, we know who you are, so here's your grades, we're done, right? And the post grades is like, okay, I'm sorry, but you're a student, you're not an instructor, so you can't do that, right? So when we implement those subclasses, there's no case statements. They're gone, right? They're gone.
So is the idea, at least in object-oriented design, like you want to avoid switching case statements in general? Is it like something to be avoided? Because you tend to present them as like a, if you do this, you don't have to use this type of thing,
Yeah, so you often will see people talking about avoiding case statements in object-oriented programming. And the reason is, as we see here, right, they propagate. And once they start propagating, if you ever need to add another case, you have to find them all, right?
Is it like that problem, like in the beginning we were talking about that whole crossword thing about finding the file, it's all in that like this one thing, it's really hard to like find and edit, but here like it just keeps spreading so it's easier. Is that like,
well, here it's spreading, right? But now if I have to add another state, I have to find all the places where that case statement is, right? In this solution, if I if I discover I need a fourth state or a fifth state, what do? I just create a new subclass, and then in one spot, there's going to be a spot in my code where I'll create that new subcase, right? New subclass. And the rest of the code just works. So it becomes easier to modify or extend the code. Because now once we have this greater state and the subclass implements different state, what do I do in the greater program, right? Well, I mean, to log in, I just tell a state to log in, and if I'm in the not logged in state, it's going to do what? It's going to ask for the username and password and check to see what's valid. And if it's valid, it's going to say, okay, they're logged in, and it'll return either a student state object or an instructor state object, right? When I call view grades, right, again, I just ask the state. I mean, view the grades, and now what happens? If you log in as a student, it will give you the student grades. If you log in as an instructor, right, the state will be instructor state, and it'll do the right thing. And if you're not logged in, right, the login state will say, I'm sorry, but you can't do that. So those case statements go away, right?
So this class right here, this grader, you actually have to have its own grader state.
Yeah, right.
You can't just throw the state in the grader class.
Well, it has. I mean, you could. Usually there's a start state, right? And usually you do it in the class, but you could put it in the constructor, right? I want to start with the state.
So I see that in the state pattern, any method which is there is returning another object of the state pattern. So you can see state equals state of login or state equals state of view grades. Is it possible to have the state object mutate itself and not have to return the object number? And even if it is possible, should we do it?
Well, so one of the issues when you implement the state pattern is who actually is in charge of the state transitions, right? What I'm showing here is the states themselves are responsible for going to transitioning to the next state. It may be you want the context to be in charge of transitioning the state, right? Now, the idea you mentioned often comes up like, well, why can't I just change my state object? And usually what happens when students try that is they put the case statement in the state object, right? They say, if I'm a student state, I'm going to do this. If I'm an instructor state, I'm going to do that, which, right? There are some languages which will allow you to do mutating, right? For example, in Smalltalk, a class can change its parent class. So then, yeah, then the state could just say, okay, make my parent class to be the instructor state, right? Or you can not just a parent class, but you can actually change the class of the current object. So you could just change it from not logged in to parent.
So if we can do that, should we do that? Or, I mean, is there any consequence to that? Or we can just make a design decision like, okay, this, I like the advantage here.
Well, not many languages allow you to do that. And there are some tricky things you have to be aware of, because when you define a class, you're defining its state and its operations, right? And where you put those, the order in which you put the fields determine what slots they are in memory. And when you change your class, you have to be careful, because if you're not very careful, the field you think you have is not what you can have, right? So that's very tricky, and so it's usually very rare that you would use that feature because most languages don't like to do that. So they're clear with it. I mean, it's the basic idea of the state pattern, right? And so, yeah, there's a bunch of different things you have to worry about. One is who defines the transitions? Does the context worry about it? When do I go from the not logged in state to the, right? You know, and it may be that when you call an operation a state, it does some computation for you. You need that result, right? And so I need that result, and then I need to do something with it. Or we could have the states themselves do the transitioning. But yeah, so it's the other problem is the example I showed had the states doing all the work, right? And basically the greater program then became a wrapper around the state. But there may be state that we need to worry about, right? You may need the user login, you may need their password, you may need to know their red ID, all this stuff, and you may it may be needed in the state object itself to do something. And so then who holds on to the state, right? Does the context hold the state and then pass it to the state when it needs it? Or do we give the state a pointer to the context and I can grab the state as it needs it? Or do I just pass all the context, all the data context needs into each state object and then it, right? So it, so it depends upon, right, there are different ways of handling it. And different uses of the state pattern will deal with it differently. The other problem is if you transition through states very quickly and very frequently, creating those objects could be expensive, right? Again, if you're on a server and you're getting 100,000 requests per minute or second, and each request you might cause a state transition on some place. If you're creating all those objects, it'll slow you down. And so then what you might do is have each state object be created all at once, and then make sure that the state object has no fields, so you can share it across different uses. Yeah, you create them, but you don't want them to have any fields. So you can use them in different times. But then you have to pass in data it needs each time, right? And if you make them have no data and you're on a server side, you could use the same state object multiple times simultaneously, right?
Would it make sense, and this might already be a thing, I don't know. Would it make sense to just have like one instance of every state sitting around somewhere?
Yeah,
then just like have a pointer to each object that needs a state, like.
Exactly, yeah.
Because then you're just readdressing pointers, and that makes the operation way cheaper, right?
Exactly. So given that the structure is virtually the same, right? What's the difference between the strategy and the state, right? One is the rate of change. Usually the strategy is like, I want to sort this thing, so here is how you compare things, and I'm done, right? I don't, like add two elements and change how it's sort, and add another element, change how it's sort. No, it's usually got my sorted collection, here's how I can sort things, and I don't change the strategy. The states you expect to change quite frequently. The exposure to change, right? Priority queue, it doesn't matter what strategy you give it, it still is a priority queue, right? And you say, give me the top one, I get the top one. You don't see any change, but the state, right? Things act differently. It's like, okay, if I'm not logged in, I say, give me the grades. I mean, I get an error message or something, right? If you're logged in and you're in a student stage, I give me the grades. I get my grades. I mean, the behavior is different. And also, frequently in a strategy pattern, right, the clients know about the strategy. They say, here is how I want to sort. Here's how I want you to order this priority queue, right? Whereas often in the state, you just like, it starts in some usual initial state, and then it transitions, and the client isn't even aware that there's a state object in there. They just know that it changes.
What do you mean by strategies all do the same thing?
They compare things. Right? Whereas the not logged in state, it does different. View grades may return an error. Whereas, the student state view grades, it returns grades. Yeah, so a Smalltalk on Lisp, we can actually change your class, so you can do this trick, but it's most languages right don't have this feature. Even Python doesn't have this feature. You can't. An object can't change its class in Python. Drives me nuts. Why this slide? Then I want to talk about single dispatch and double dispatch. So here, let's look at the full examples. I got a parent and a child extends parent, and then I got a class bar, and it has two methods, right? And each method, one is argument of type parent, and one is type child, right? And so I create a bar object and a new parent object, and I call foo, and I pass in test. What gets printed? What comes out? Parent, right? Now I create a child object, and I assign it to x, and now I call foo again with x. What gets printed out? No, it's parent. Why is that? Well, because at compile time, the compiler selects which function, which method is called. At runtime, you decide which class to start looking for that function or method, right? So at compile time, when you do this, the compiler says X is declared to be of type parent. And so we're going to look for something whose argument contains a parent thing, and its name is foo. And at runtime, we then look at test and say, oh, what's the actual class of the object test, right? Oh, it's bar, so we go to the bar class and look. Now we do this, right? Now we get child, right? Why? Well, because the declared type of y is child, so at compile time, the compiler says, oh, I need to find a function called foo with argument of type child. This is called single dispatch. It's called single dispatch because at runtime, the only thing that's going to change our mind of which function is called is the receiver of the object. Right? We're used to in Java or Python, right, or Swift, that when you call a method an object, at runtime you figure out what class that object is and go to that class and look for that method, right? If it's not there, then you go up the class hierarchy, right? So we only dispatch at runtime based upon the receiver of the object, right? The name of the method and the arguments of the method, the compiler chooses which method to call based upon those at compile time, not runtime. So far, so good? Now, some languages have what they call multiple dispatch. So one language is Julia, and so we have a bunch of foo functions, and we've got 2 arguments each, and it's integer, integer, integer number, number and integer, number, number, number complex, right? And they all return different values. And when I call foo12, it's like, oh, it's integer, integer, and so I'm going to call that, and so I get integer, integer back. Here, oh, it's an integer and a number, right? And so we get integer number, even though we could have said it should be number, number, right? Because both are numbers. But the language is designed so at runtime, we check the type of the arguments and then go find the function that has that name and those argument types, which is different than what most languages do, right? Java and Python only have single dispatch. They only, at runtime, select which method to call based upon the receiver of the message. Julia allows you to have multiple functions with the same name, same number of arguments, but the argument types are different, then at runtime, you'll figure out which one to call.
It was not because of the sequence, right?
No, I could interchange that order of those things. Right, right. It doesn't go from the top to bottom because at runtime, what's top, what's bottom, right? These are tables and then I can do this, and that becomes a fraction, which is a number. And so now I'm going to get a number and integer, right? So right, and so we have various ones, right?
For Java, then we would get integer all the time.
If it was Java, you'd probably get some compile errors because it says, I'm sorry, I can't figure out which one to call, right? Because it has to know at runtime, at compile time, which one's going to call. Now, the reason I do it in Java, I mean, Julia is, it allows you to do some fancy things like, well, you know, if you want to raise a number to a power and the exponent is complex, that's a complicated operation, right? It's complicated to take a number raised to a complex number and you'll have weird calculations. And if you're going to raise a number to a real number, and again, if you're going to raise 2 to 3.574, I mean, that's a complicated calculation, right? But if the exponent's an integer, that's a simple calculation. It's really fast. And so it allows them to create special algorithms that are simple for special cases so that when you call the general case, you're like, okay, this is, you only raise the power to integer, so why use this complicated slow algorithm when you can do this fast one? Was that? No. No, C++ doesn't have multiple dispatch, no. You know, you'll get some of it with templates, but not the whole thing. Because again, you have to decide at compile time which one to call. And that's based upon the declared type of the arguments rather than the actual types of the arguments. And there's this famous principle in software engineering where we want modules to be open and closed at the same time. Your module is open, you can add and remove fields, add and remove methods, and it's closed if you can use it for by other modules, right? Once you start using the module, changing it causes problems, right? Because then, okay, then you have to find everyone who uses it and tell them, I'm sorry, but it's changed now, right? And so there's principles of we want modules to be open and closed, right? Right, so open for extension, but closed for modification. And the way we get this in object-oriented programming is we subclass, right? So the original class doesn't change, but we can then create a subclass which extends it. If you got double dispatch, we can do that without inheritance, because now at runtime we choose which one to call based upon the actual types of the arguments. And so we can then modify what types the arguments are, add a new function with that type to do things. Now, the reason I'm talking about this now is that means that if we want to implement the state, we want this class to basically change its state, right? If we've got multiple dispatch, we can implement this pattern differently just by creating view grades as a not logged in, view grades as a student object, view grades as an instructor object, right? And so we don't need this whole class hierarchy and then also encapsulate inside of a container, a wrapper object. So what we're seeing, right, is, the basic design pattern books came out in 1995. And as languages have changed and evolved over time, right, different language features have come out which allow us to achieve the same thing in a completely different way. And Clojure also has multiple dispatch, what they call multi-methods. But again, it's just the basic idea is that you have to be careful because different languages have different features, and they then may allow you to implement the pattern differently. For example, small talk and list changing the class of an object, or multi-methods, right? Or multi-dispatch allow us to get the same effect without having this class hierarchy at all. Any questions? So I'm going to go on and talk about some patterns for next assignment. I'm going to start with a warning, right? Before we cover the visitor pattern in class, you really, really want to read the visitor pattern. And then after we cover the visitor pattern in class, you then want to reread the visitor pattern again, right?
So we're doing that one next class then?
Probably next class, but yeah, I mean. And the visitor pattern, when I give assignments a visitor pattern, it's common for students to implement completely wrong. Like, oh, this is complicated. I can make it simpler by doing this and this and this. And I go, yeah, but that's not the visitor pattern. Right? And so there's this weird bouncing back and forth that happens that you need to understand what it's doing and why we do it that way. Right? So undo, right? You know, there's all kinds of cases where you may want to undo something, right? We do some operations. So text editing is common. How do you redo? Can we do multiple undos, right? And one of the patterns, we talked about the command pattern, how we can use that for undo. We also talked briefly, there's some situations where you may not have an inverse, right, for an operation. And so another pattern which supports undo is the Memento pattern. And the basic idea of the Memento pattern is very, very simple. You just store the state, right? You take the state of the object and you store it somewhere else. If you want to undo, then you take the old state that you stored someplace and restore it. We're done, right? And if you want to support multiple undo, then every time you change the state of that object, you can make a copy, right? And put it on a stack, right? Like you did with the command processor. And then undo, you just take, well, just pop off it and take this state and stuff it back into that object, right? Yeah, so if you want to undo the state of an object, you need two things, the old state and a reference to that object, right? So the basic idea is, I mean, it's trivial, right? It's just copy the state. Now, it does add without violating capitalization, right? The problem is if you just have a method say return state, then I can get the state and then I can muck with it, right? And the problem with that is if I can do it, then someone might do it, and then that could modify the behavior of that object in the ways we don't like, right? So how do we put this? How do we get the state out of it in such a way that is safe, right? Well, the answer is your object has a get memento method. It then stores the state inside of a memento object, which only allows the originator to access it, right? And then you return that. So in the Java world, you can do that fairly easy by dealing with protection levels, right? We could make memento class internal class, inner class, or give it package level access, right? So other people can't deal with it. And so there are no public methods available on the memento object, and so no one can actually grab what's inside of it.
So sometimes to protect an object, we create a copy of it and return a copied object, the new object. Is it similar to what Memento does? So we definitely wrap state in a Memento object, but generally, like in simpler terms, we generally copy the things. So is it the same?
Is it the same? In Java, making a copy is sort of a cheap way of doing it. There are a couple of issues with that. One is then once I make a copy, that copy, we can now modify its state, right? And it's no longer the state we want. Usually in Memento, it's like, okay, there are no public methods on it, so there's no way to modify what it holds. The other issue is one of the problems with Memento is every time you make a change, you need to copy the state. How big is that state? Don't know, right? For many things, it's probably pretty small, but there will be times when it's big, right? And what happens if there are different pieces of state in there, and we change a small one, and the big one doesn't change? Oh, do we really need to then copy the entire state of the object, or can we just copy what's changed? Right? So when you read a pattern in the book, and we go online and read about mental pattern, they'll just say, well, we're just going to copy everything, right? But depending on the situation, if you're taking a lot of mementos and the state is going big, then do you want to copy the entire state? Can we get by with somehow being smart about it and copying pieces of the state, and then when I give the mento back, right, it knows how to just restore that piece of state that changed. So here's just sort of a cheap way of, just create a hash table, and it sort of becomes a generic memento where I can, give a key and a value, and right, and then I'm making them protected so that general can't get to them, and put them in the same package as the class that it's going to save. Right. And then we can have, create memento and restore state. And here all I'm doing is I'm copying the entire state right over, and then I copy it back. But I could be clever, right, and do something like have the get state have. Well, actually, no. I'm giving get the state, the key, and the current value, right? And so what I can do is, if I didn't change the name, why store that state in Memento? And so then, when I go inside my old state object, if the name doesn't exist, I just return the argument past tense. Again, it's pretty simple, right? I mean, you just copy in the state.
Does the Memento object saves the state of the particular class?
Yeah.
Of the particular class? Or?
It just saves the state of a particular object, right? It gets more interesting, right, when you have an object and some of the fields are objects, and then, right, because part of the problem, well, yeah, here we've got this problem, right? You got a vector or a collection. If I just store it in Memento, that doesn't work. Why? Well, because if I put this Memento aside and then my complex object changes something in the vector and my Memento has a pointer to the same vector, we just lost, it's no longer the state we want, right? That's why I cloned it, because, right? So the idea is simple, but we have to be careful. When our fields are objects themselves, which hold states, do you just give your Memento a reference to it, or do you have to copy it? Right? Then, what happens if the one you want to save has a field with some sort of object, right? And that object has fields, and one of those are objects, right? So how far do you copy down? You have to worry about that, right? Because if the whole goal is to take the current state of the object and set it aside, so at some point later I can recover it, I have to make sure that state I've saved cannot change. And if the original object has they both have a reference, however deep, to the same thing, and then the original object changes that thing, no good, right? So is the problem clear? You don't have to worry about the strings in Java because strings are immutable. You can't change them, right? Integers are immutable. Don't have to worry about them, right? As a vector, it contains objects, and so that can change even though the original vector is not replaced, right? So that's why that works. New integer because I'm putting the hash table, right? And then I have to clone it. Well, we've talked about this, right? The problem of storing the history internally is that Are you sure every time you use that class you need to save its history? Probably not. And how big can that history get? Pretty big. And now whatever this complex object is doing, do you want it also to have to manage this history and turn history on or off and limiting the history, right? Yeah, some consequences. I mean, it's expensive in two ways, right? You have, you have to copy the state, and the copying could result, copy, right? And expensive in terms of just memory, because if you're making lots of changes, then you may make a lot of mementos if you want to be able to have undo all the way back, right? In space. And so we need, basically two types of interfaces for Memento. One is for the public, so they can't do anything somehow, and then we need the actual content with the object that contains the original state has to be able to access the state, get it out of it. And so in Java, again, we can do crazy things like use an inner class to help deal with this. Yeah, C++ is, we do some tricks too. Then we get to, why not just clone it, right? In Java, but then you've got the question of how far do you clone, right? And that brings in the issue of shallow cloning, copying, or deep copying, right? So here's I got some sort of door object and has reference to rooms. A room may have chairs and other objects inside of them. And so when I copy the door, do I copy just the door or do I copy everything, right? So this is a shallow copy. And it's not going to work for the Memento, right? So here's a deeper copy where when I copy the door, I also copy the rooms, but I'm not copying what's in them. And then finally, a deeper copy where I just copy everything. Right?
Just make the room clonable. Could you make that?
Yeah, and then you have to make the chair clonable too. Right? And the table clonable, yeah. And then once I had a student who said, yeah, at our company we have shallow copy, deeper copy, a really deep copy, an even deeper copy. I mean, there's like 10 of them. Because every time I came across a situation, like, oh no, we needed another one to go deeper, or yeah, one will be safe, right? And you have to worry too about what happens when object A points to B and B points to C and C points to A. Oh yeah, that's fun. The few times I was able to teach data structures, I give that assignment. Here is a circular reference, copy it.
That would be terribly hard to do. You just wait till you find, like, go all the way around the queue until you find something that's identical to the first thing you did, right?
But what if A points to B and B points to C and C points to D and D points to B? You don't know where the circularity comes in. You need some way of identifying when you came back to the same thing, right? How many people here know what a copy constructor is in C++? Well, then I won't need to worry about it because clearly no one is programming in C++. Because if you were programming in C++, you would know. You would know. Yeah, so in Java, when you copy, if you're going to use cloning, you have to worry about are you deep copying all the way down or not.
This might be kind of a goofy question, but in terms of deep copies, like, is there, aside from just simplifying it to a function call, is there any reason that you would prefer doing that over just like taking the features of the object you're going to copy and calling that constructor and making a new one? It's like the same thing, isn't it? It's intended to be.
The constructor may not have parameters for all the features of the object.
And they can probably shift around as the object is used.
And the constructor could modify things.
Okay, that makes sense.
You know, I presented Memento as sort of an undo mechanism that sort of hides some useful things where when you're doing what if, what happens, this happens, right? Memento can be useful because, okay, I want to try the experiment. I want to see what happens under these conditions. Okay, I'll make a bunch of changes, see what happens. Oh, I don't like that. Let's go back to where I was and try something else, right? Say you're dealing with financial information, like, okay, what happens if I buy this house? What happens in the next 20 years, payments, and I assume this is my income, how much can I save? And so we do a bunch of calculations. Okay, well, I guess we're not going to buy that house. How about we buy this house? Well, let's go back to where we were, right? And so making a copy of the state before we do our experiment becomes useful, right? And one of the things the functional programming does is they say, let's make all state immutable, right? And if all your state is immutable, then you don't need, all you do is save the original object, right? Because when you change it, you get a different one. So the pattern goes away because you don't need to make a copy because when you make a change, you're getting a new version, right? And there's actually this database called Diatomic that they carry this idea of immutable data to a database, right? When you enter the data in a database, you can't change it. So when you want to add a new value, it does the same thing a functional programming does. Is okay, it makes another version of it, and that has some very nice features. It means that reads and writes can be basically independent because you don't have to worry about locking anything when you're writing to it because you never modify anything. It means that if you need to know the history of what happened, you got it, right? You know, for financial transactions, for financial institutions, they need a history, right? Every transaction, and they can't lose it. They can't say, well, we currently got $5 million, but we don't know how we got here, right? It's not an option, right? So every time they make a change, right, you get the complete history automatically. Again, it's just another example of, as languages change, right, and hardware changes, we can do more things. 30 years ago, this was unthinkable. It's like, you don't have a memory. Hard drives are too small, memory's too small. You're not going to do this. Now it's like, how much memory? How much memory do you have in your laptop?
16 gigs.
When I started teaching, I had classes like 100 students, and using machines that the same machine. All the students use the same machine. They didn't have a gig of memory. It had like 200. Maybe 200 megabytes. That's it, right? So that's a mental pattern. And next time we will look at the interpreter pattern, and if time permits, the visitor pattern.